Welcome to the 4.4 notes for Math 126. We're going to look at trig functions for angles that maybe are not explicitly written on our unit circle. I did want to show you this unit circle though, just because I kind of like the way that the angles are written kind of along the terminal side, which I think makes things nice and clean. So thought that that might be something that was worth a moment of your time to look at. Okay, so basically the strategy that we'll be using here is you'll be like plotting the point and drawing a right triangle and using the Pythagorean theorem in order to find any missing sides. And then you're going to be able to find your trig functions. So why don't you kind of use that as a little bit of a guide and try exploration A and B. Pause the video, and then when you're ready, you can restart it and see how I handle these. Okay, so point P is located at 2, -3, which is here. And this is going to be the terminal side of some angle. Oh my gosh. Like that. Now, when I draw in the point, this would not necessarily be on a unit circle. You can see that that radius clearly is longer than 1 unit. However, that doesn't mean we can't find sine, cosine, and all of these others. It just means that we have to go back to like opposite over hypotenuse and etc. in order to do that. But what I'm going to do is I like to draw a triangle with the x-axis, and I'll call this theta right here. And again, point P is at 2, -3. So this is 2, and this was -3 right here. And what I want to do is find all 3 sides of the triangle. So let me find the hypotenuse really quickly by using the Pythagorean theorem. So I'll use a squared plus b squared equals c squared. And I'll get a 13 that I'll square root. And I'm going to pick the positive. What we're going to say is that hypotenuse is always a positive value. So then my sine would be the opposite over the hypotenuse. And if I rationalize, I'll get -3√13 over 13. Cosine is the adjacent over the hypotenuse, which would be 2√13 over 13. Tangent is opposite over adjacent. Or I could do sine over cosine. It would reduce down to this. It's actually faster in this instance to just use opposite over adjacent. Cosecant is the reciprocal of sine. I'm going to use the non-rationalized version. Oops, I almost lost my negative. Secant is the reciprocal of cosine. If I use the non-rationalized version, I can get to that answer faster. And then cotangent is the reciprocal of tangent. Exploration B, point P is at -3, -5. Let's see if I can count today. And I like to make my right triangle with the x-axis. So -3 would be how far to the left, -5 is how far down I went. And then my hypotenuse here, if I use the Pythagorean theorem, let's see, that's 34, and so this would be the square root of 34. Now, technically, there's a plus or minus, but we're going to say that this is going to be a positive hypotenuse here. So the sine would then be -5 over √34, opposite over hypotenuse, and don't forget to rationalize. Cosine is the adjacent over the hypotenuse. After I rationalize, I get -3√34 over 34. Tangent is opposite over adjacent. The 2 negatives would cancel out, leaving me with a positive. Cosecant, if I use the non-rationalized form, is the reciprocal of sine. I'll just move that negative to the top, or it could be out front. Cosine would be -√34 over 3, and cotangent is the reciprocal of tangent. All right, signs of trig functions. We've kind of already seen this. We're just going to formalize it. In this quadrant, in the first quadrant, everything is positive and positive. So cosine and sine, being our ordered pairs, would both be positive. In the second quadrant, we would have a negative for cosine and a positive for sine. In the third quadrant, both will be negative. And in the fourth quadrant, cosine is positive while sine is negative. These look like little faces to me. So knowing the sign will tell you what quadrant and vice versa. What is a quadrantal? A quadrantal is one of the angles that is right along the x or y axis. So like 0 degrees or 0 radians, 2 pi, 360. There's a lot right here and on that side how we could name this depending if we want to keep going around the unit circle multiple times and loop around. This would be pi over 2, pi, and 3 pi over 2. They're your quadrantals, or quadrangles is the other way I've heard people discuss them. So sometimes there's more than one term. All right, we want to find the sine, cosine, and tangent at the 4 quadrantal angles listed. Well, remember, sine and cosine are just going to be your coordinates at each one of these. Just be careful. Make sure that the first number is how many you're going right or left. The second number is up or down. So we want the sine, cosine, and tangent. So for 0 degrees, the sine is the y coordinate. The cosine is the x coordinate. Tangent would be sine over cosine. 0 over 1 simplifies to 0. At pi over 2, the sine is the y coordinate, which is 1. Cosine is the x coordinate, which is 0. And tangent is sine over cosine, which is an undefined value. At pi, the sine of pi is the y value of 0. The cosine of pi is the x value, which is -1. The tangent would be sine over cosine, which is 0. At 3 pi over 2, the sine is the y value. The cosine is the x value, and tangent will be undefined because when I do sine over cosine, I get a 0 on the denominator. Okay, for these next ones, we're going to have a little bit of information, and we just need to decide which quadrant that would be. So for number 2, sine is negative, which means we have a negative height. Cosine is also negative, so we're on the left side. Since they're both negative, we are in quadrant 3. Little trickier on number 3, tangent is negative. Tangent is negative. Now remember, tangent is a quotient. Tangent is sine over cosine. So what this tells me is either sine or cosine is negative. Not both, because if they are both negative and we divided them, we'd end up with a positive. I know that cosine is positive, which means I'm on the right side since the x value is positive. And this would mean that sine must be the one that is negative. So we must be below the x-axis, and we have landed in the 4th quadrant. These next ones are kind of similar to that, where it will be helpful for us to figure out what quadrant we're in so that we can do these. We might have to use the Pythagorean theorem some, and we can put these into triangles. So drawing a picture and drawing a picture in the correct coordinate will be helpful. Okay, so I know that tangent is negative. Again, that means either sine or cosine is negative. Well, cosine is negative, so I must be below the x-axis, and that would mean sine has to be positive in order for us to divide and get a negative tangent. So if, oops, I did that wrong earlier. If cosine is negative, we're to the left. My apologies. But sine is positive, so we are above the x-axis. This means we're in the 2nd quadrant, quadrant 2. So that's how we're kind of landing on that. Okay, so since I know we're in quadrant 2, I'm going to work on finding the sine and the secant. Now, I don't know actually if these values are going to have a hypotenuse of 1. Looking at them, I suspect they won't. So I probably am bigger than the unit circle. So I'll probably be using like opposite over hypotenuse, etc. Okay, tangent is opposite over adjacent. So opposite and adjacent would be the values of 1 and 3. I'm going to use the Pythagorean theorem to find the hypotenuse. So I'll do legs squared plus legs squared equals hypotenuse squared, and I'll get the square root of 10. Remember, we will use a positive value for that hypotenuse. Now that I know these, I can find the sine and the secant. The sine will be the opposite over the hypotenuse, and I will rationalize that as negative root 10 over 10. The secant is the reciprocal of the cosine. So it'll be hypotenuse over adjacent, which would be root 10 over 3. So why don't you pause the video and try 4 and 5, and when you're ready, you can compare. So for number 4, cosine is positive. So I'm to the right of the y-axis, so where I have positive values for x. And the cosecant is negative, which also means the sine is negative. Since they're just reciprocals, they'll have the same sign. So I am below the x-axis, and I must be in the 4th quadrant. I'm going to draw a triangle. I always will draw this triangle with the x-axis and use theta in there. The secant, or the cosine, is 1 over 2. That's my adjacent and the hypotenuse. And I can see this makes sense that sine would be negative because I'll be going down here. And I want to find the tangent and the cosecant. So I'm going to use the Pythagorean theorem. So legs squared plus a missing leg squared, which I'll just call that b right here, is equal to the hypotenuse squared. So b squared is 3, and b is plus or minus the square root of 3. Now we already decided that this is going down, so I'm going to use the negative root 3 here. So the tangent of theta would be the adjacent over, the opposite over the adjacent. The cosecant is the reciprocal of sine. So sine is opposite over hypotenuse, so I'll do hypotenuse over opposite. And I'll just, rationalize this and move the negative out front to negative 2 root 3 over 3. Number 5, the tangent is negative. What that tells me is that either sine or cosine is positive. Either sine or cosine is negative. Since sine is positive, cosine must be the one that is negative. Cosine being negative means we're to the left of the y-axis, but since sine is positive, we are above the x-axis, so we must be in the 2nd quadrant. And I'll draw my picture there. I'm going to draw a right triangle in this quadrant, draw it with the x-axis. We know what the tangent is. Tangent is opposite over adjacent, so I'll use the 4 and the 3. Now, it doesn't make sense for the negative to be at the 4 because that's going up. So the negative here must actually belong with the 3, which is the cosine. You might recognize this as a triple, 3, 4, 5. Otherwise, you could use the Pythagorean theorem. I want to find the cosecant of theta, which is the reciprocal of the sine. So instead of opposite over hypotenuse, I'll do hypotenuse over opposite. And I'll get 5/4. And then the cosine is adjacent over hypotenuse, so negative 3/5. All right, our next kind of little topic for this lesson is a reference angle, which will help us be able to find sines and cosines and tangents of an angle that we may not initially recognize. So a reference angle is basically the smallest positive acute angle that's between the terminal side of an angle and the x-axis. And basically, it's going to be the angle that would give us an equivalent value as that terminal side. So a lot of times what I'll do is I'll just basically be looking for this. Like if I have some angle like 135 degrees, I just want to be able to see kind of what its complement is, would be a way to think about that. Now, I want it to be positive and acute. So if the angle's already in the first quadrant, it's already positive and acute, and that angle is the same as its reference angle. By the way, you might wonder how to say this. This funny symbol is a hat symbol. This is theta hat. it's not a super big deal that you know that symbol. It's just kind of the way it's commonly written. In quadrant 2, what you want to do is subtract from 180 or from pi so that you could see what this angle is right here. That's the reference angle. Quadrant 3, same idea. It's just you're going to actually do the angle minus 180 instead of the other way around. I'll show you why in a minute when we have a picture of it. In quadrant 4, we can actually subtract from 360 or from 2 pi. And it's always an acute angle unless it's already 90 degrees. And then it would be 90 degrees, which is kind of rare but can happen. All right, we want to find the reference angle theta hat for each one of these. So for me, I draw a picture. You don't have to, but it helps me. So 180 degrees is right here. 210 would be here. The way I think of it is, what's the angle that it would make with the x-axis? That's how I do it. But you could do 180 minus, or 210 minus 180, and we'd get 30 degrees if you want something computational. I am more visual, so for me, I just want to see what's the angle between that terminal ray and the x-axis. That's pretty much it. 7 pi over 4 would be the next one. 7 pi over 4 is this one. So how far away is that from the x-axis? Well, that's 1 more pi over 4 away for the reference angle. But you could do 2 pi minus 7 pi over 4 in order to see that. Think of 2 pi as 8 pi over 4, and that'll give you the pi over 4. 580, since it's over 360, I'm going to start by finding like a coterminal angle here. So let me subtract. Let's see, I think that would be 220, which 220 would be somewhere over here. And if I want to just see how far is that away from the x-axis, that is 40 degrees. So the reference angle is 40 degrees. And you could do 180, 220 minus the 180. Sometimes kids go, do I subtract from 180 or do I subtract 180 from the angle? Whichever would give you a positive. That's how you kind of want to think about it. Okay, well, I'm going to start by finding a coterminal angle for this one. I'll add 2 pi on here, and I'll get negative 5 pi over 3. I'm actually going to add 2 pi again to get a coterminal angle. I get pi over 3. What I want you to notice is pi over 3 is positive and it's acute. It's in the first quadrant. So anytime we land with something that's in the first quadrant, this is its own reference angle. Any angle in the first quadrant is its own reference angle. For this one right here, I'm just going to subtract 2 pi. Actually, it turns out to be one that we already did. 7 pi over 4 is right here, which is 1 pi over 4 away from the x-axis. You could subtract from 2 pi to see that if you'd like. You can either subtract from 1 pi or 2 pi, depending kind of what quadrant you're in. All right, well, we're still going to use reference angles here. And the point of the reference angles will be to try to find, if we write the reference angle, then we can help find the answer for this problem. So I want the sine of 300 degrees. Well, 300 degrees is over here. And notice that it is 60 degrees away from the x-axis. So this is related to a 60-degree angle. And remember, a 60-degree angle, if I think of 1, 2, 3, and 3, 2, 1, for the sine and the cosine, here is the sine and cosine for 60 degrees. Well, this is basically a reflection of that, but because we are now below the x-axis, we would have the sine as a negative. And we want specifically the sine here, so we're going to take the y value. So by recognizing that 300 degree as having a reference angle of 60, we know then that it would have the same coordinates as a 60-degree angle, but with sign changes to reflect what quadrant we're in. So the secant of pi over 6, negative pi over 6. Well, negative pi over 6 means going pi over 6 this way, which means it's pi over 6 units away from the x-axis. So the reference angle is pi over 6. And pi over 6, if we do 3, 2, 1, and 1, 2, 3. So this is for pi over 6. Now we're going to do negative pi over 6. And in this quadrant, what we'd end up with is the sign is negative. We want the secant, which is the reciprocal of the cosine. So I'm going to do 2 over root 3 and rationalize it. All right, number 14. This angle right now is more than 2 pi. So I'm going to go ahead and find a coterminal angle here by subtracting 2 pi, or 12 pi over 6, to get 5 pi over 6. Now this angle's not acute. So I'm going to figure out the reference angle as one of many different strategies in order to solve this problem. Evidently drawing circles is incredibly hard today. 5 pi over 6 is here, which is pi over 6 units away from the x-axis. So this is related to a pi over 6 angle. Pi over 6 is root 3 over 2 1/2. We were just looking at that. So 5 pi over 6, which is coterminal with 17 pi over 6, would have the coordinates of negative root 3 over 2 1/2. And I want the cosine, which should be the x-coordinate of this. Sine of negative 22 pi over 3. Well, first of all, I don't love that this is negative, and I also don't love how much bigger it is than 2 pi. So I'm going to go ahead and start adding on a series of 2 pi's. Now I could add on more than one, because clearly, this is going to take a couple. I could add on, there's 1 2 pi, here's 4 pi. I could add on 6 pi. Or I guess that actually would be, 6 pi. Yep. Or I could even go loop around again and add on 8 pi. Now you could do this one at a time if you wanted. So if you wanted to, you could add on 2 pi to get negative 16 pi over 3, and then add on 2 pi again to get negative 10 pi over 3, and then add on 2 pi again to get negative 4 pi over 3, and then add on 2 pi again. And that'll finally land you at that positive 2 pi over 3. So do that how you'd like, but we want to make sure that it's a multiple of 2 pi. So 2 pi over 3 is positive, but it's not acute, so it's not a reference angle. 2 pi over 3 is pi over 3 units away from the x-axis from pi. So the reference angle here is pi over 3, which has, this is if I do 3, 2, 1, this would be 1/2 and root 3 over 2. 2 pi over 3 would then be negative 1/2 and root 3 over 2. And so I want the sign, which is root 3 over 2. And that is the end of the notes for this lesson and also for this unit. Thanks for watching the video.